In 1973, there was an ongoing debate in the statistical sciences about whether graphs were useful tools for understanding data when compared with typical statistical analyses. Francis Anscombe argued that graphs were crucial to understanding data and published the following example to illustrate just why that is the case. His example illustrates the importance of graphing in helping humans understand trends in their data, as well as the potential impacts of data with different types of anomalies, such as outliers. So take a look at this table. It has 4 different series of XY coordinates. Hit pause on the video and take a couple of minutes to determine whether you see similarities and whether you can determine anything about the shape of the data. Now do this without using some external tool. Don't take notes, don't use Excel. Just use your basic visual perception. All right, so hit pause on the video and I'll be right back. Okay, were you able to identify anything? Now we'll come back to discuss that in a second. William Playfair was one of the pioneers of modern data visualization. He identified the issues that people have with understanding data when it's presented in tables like we just saw. And here's a quote from Playfair. "Information that is imperfectly acquired is generally as imperfectly retained. And a person who has carefully investigated a printed table finds, when done, that he has only a very faint and partial idea of what has been read, and that, like a figure imprinted on sand, is soon totally erased and defaced." Gosh, I really wish we still wrote like this. But what he's saying is that no matter how long you stare at a table, the insight you gain will be lost after just a little bit of time. So let me ask you, do you remember, without consulting any notes, the specific differences you found between series? Do you remember the highest and lowest numbers for each series? For instance, potentially the shape of each data series. It's likely that you're losing detail about those data series each minute we spend away from looking at those tables. Now, Playfair developed a number of graphs that we still use today. Trend graphs, the pie chart, column charts, and more. Now note, his graphs had to be drawn by hand, so they weren't widely used in business. But today, we have the power to use his graphs every day to drive understanding of data. Okay, so back to Anscombes Quartet. Most people readily identify that the x coordinates are the same in the first 3 series, but different in series number 4. But one of the reasons that this is so easy to identify is because the coordinates are sorted in the same order. Do you think this would have been harder to identify if the cases had been sorted in different orders in each series? In addition to series 4 being different, people sometimes try to identify a slope for 1 or 2 of these series, but these slopes are almost never correct. Now, for the crazy point, these 4 data series are absolutely identical when you perform typical statistical analyses such as linear regression. They have the same number of observations, the same means of x and y, the same regression line, the same r-squared, and other fit statistics. So from a statistical perspective, each of these series are the same. That means that all of the series look like this graph. However, when we look at each series independently, we see a different story. Series 1 looks like a pretty good fit for our slope. But what about series 2, series 3, and certainly not series 4? Now, obviously, these groups of data are different, and if we had not visualized this data, we would not have been able to identify the differences between these data sets. Now, Anscombes Quartet is a very simple example. It only has 11 data cases, and these were easily readable. Even with this simple example, there's a low likelihood that anyone could identify the differences between the data sets. So, statistical methods are great tools, but they may mask true differences in data. And visualization is crucial to the understanding of comparisons between data points and especially between data series.